Welcome to May's Leetcode Challenge. Today's problem is cousins in binary tree. So say that we've been given a binary tree as well as an X and a Y. We're going to be asked, are these two cousins? And the cousin definition is that they have the same depth but have different parents. So depth of binary tree is basically its height. So it starts with a depth of 0 here, depth of 1, 2, and so on and so forth. So here with the numbers 3 and 4, we can see that they wouldn't be cousins because even though they have different parents, they're in different depths. What about this example, 5 and 4? 5 and 4 are at the same depth. They have different parents, so they are cousins. And finally here, 2 and 3, they're the same depth, but they have the same parents. So no, they're not cousins. They're brothers, I suppose. So how would you solve this? Well, we're going to have to traverse through the tree and basically figure out a way to see if these values exist. Does the x exist inside this tree? Does the y exist inside this tree? And if so, track its depth for x as well as y, and then track its parent, x and y. And once we have those values, we can just check to see, all right, does x and y exist? Do they have the same parent? Or I should say, are they in the same depth? And do they have the same parent? And if they don't have the same parent, they have the same depth, and they both exist, then they're cousins. So in order to solve this, usually you'll have to use a helper method. And what I decided to do was just write a depth first search function. And we need to pass in a bunch of things because when we traverse through this tree, once we hit the point of value equaling one of the numbers, we need to be able to know who the parent was. We need to know what the depth was and store that somewhere. So I'm going to create a tracker up on top here, just make it a dictionary. And for this function, I want to pass in the node. I'm going to pass in the parent, the depth, as well as the x and y. And the reason for that is we might as well pass in both and track them both. The very first base condition would just be to say, all right, if not node, we're going to return nothing. So after that, it's going to recursively call the DFS function on left. We're going to pass in node as its parent, right? Because that's the parent. And we're going to pass in the depth plus 1 as well as x and y. And we'll do the same thing with right here. Now, once we get to the end, we're going to start checking to see if this tracker, if we should keep track of the parent for this node value. So what I would do here is say, all right, is node value in one of the x and y's? Because if it's one of them, let's keep track of it. So we'll use the value to say we're going to make that the key, and we want to store a tuple of the parent that we've been passing as well as the depth. And at this point, the depth would be plus 1, so it would be the depth at where this child is. So that's it. After that, you would just call the function. You would say pass in the root first. We'll pass in none as the parent since the root doesn't have a parent. We'll pass in 0 as the depth as well as the x and y. And if this finishes, we should have a tracker that contains both x and y and their parents and depths. So after that, let's set a boolean here and say, all right, for us to know if this is cousins, we want to see if first the tracker contains the x value and the tracker contains the y value. So they both exist, right? And if they both exist, we want to check, are their depths the same? So to do that, I think we could just type in x, and we know that the second item inside of that equals the depth. So we'll track that and say the depths equal each other. And finally, we also need to make sure the parents aren't equal to each other, right? So how we would do that is use the first item inside of the tuple and say, make sure that the first item here does not equal the first item for y as well. So that would give us a Boolean to tell us whether the cousins, they're cousins or not. And after that, we'll just return cousins. And let me make sure I made no typos. So with example 1, 2, 3, 4, looks like we did return a false. Let's try returning a true just to be sure of our logic. And I'm gonna make a custom case. That's x equals 5 and y equals 4. This should equal true. And indeed, we return true. So let's submit that. And it's accepted. Now, normally when you create these functions, you don't want to pass in so many variables. But unfortunately, for the way I solved it, this required all 5 of these. There are ways that you could probably return rather the parent and the depth, but it got really complicated. This seemed a lot more understandable to me. All right, that's it. Thank you.